Hello, my name is Gerhard Adam, and in this set of modules we will continue exploring the mainframe environment. In particular, we will discuss the most common types of file, the sequential file, and we will look at data sets in general. Within the ZOS environment, some things are done differently than on other computing platforms, and those differences can also be a source of some initial confusion. The concept of a data set is simply a more formal name for a file as defined as ZOS. In practice, the use of file or data set is somewhat casual, with both being used synonymously. In the next few slides, we will look at the concept of records versus characters to record data and how records can be grouped together to form larger physical blocks. In addition, we will examine some of the elements associated with naming data sets and assigning space for the data set to occupy. The use of data sets, or files, is fundamental to every computer system. This is the means by which data is created and stored for future reference. In the ZOS environment, however, data sets must be defined before they can be used. This may seem to be an unusual requirement, but it is important to remember that overwhelmingly the data used on mainframe systems does not resemble the typical types of data we encounter in our own personal use. Text files, JPEG images, spreadsheets, and PDFs are not the data types routinely encountered on mainframes. Unlike other environments where creating a file may be as simple as declaring it as new, in ZOS the file must already exist or it must be created in advance of being used. As a result, the programmer must provide required definitions that aren't necessary on other systems. This requires the assignment of a name, specification of how much disk space will be used, and a definition about the data characteristics that the file will have. As a result, the ability to create data sets is fundamental in ZOS and is a necessary and required skill in order to define the data sets that will be used by programs, whether it be for testing new applications or for usage in online production systems. Another point that we need to review is the concept of the access methods. In the previous module, we indicated that access methods are operating system service routines that provide the I/O functions for programs requesting reads or writes of data. However, it is more than that, because it allows a program to work with files that may have a variety of internal organizations. In this slide, we can see some of the types of organizations that exist, although we will only be dealing with the sequential files in this module. This should not be confused with databases, where there is a separate piece of software that is responsible for accessing data and returning results. Access methods are a direct programmable way for individual programs to work with these different forms of data organization. The acronyms in this slide simply refer to the formal name, so that QSAM is the Queued Sequential Access Method and BSAM is the Basic Sequential Access Method. For our purposes, these names aren't important, as they are relevant only to programs in determining the form in which they code their I/O operations. As already indicated, the sequential access method is for data that is read or written in sequential order. The BPAM, or partitioned access method, will be discussed in the next module and refers to a dataset type called a library. The remaining access methods will not be discussed in this unit, but are described as indexed, which is a VSAM structure that allows a portion of the data to be used as a key, which is placed in an index to allow lookups for specific records. An example would be something like an account number. Direct access, or BDAM, is infrequently used because while it allows the ability to directly retrieve a specific record from a file, it is complex to develop algorithms to provide good results. A linear dataset is also a VSAM type file, which can be used to capture unstructured data as it would exist in memory. This method is often used by database systems to store tables. Now let's explore the difference between character files and records. In this example, we can see a typical file as it would be recorded in Unix or Windows. The data is written as a string of characters whose end or termination is determined by the carriage return line feed bytes. In this example, we can see the hexadecimal 0D and 0A characters indicating the end of the character stream. This results in a loose definition of what we might consider to be a line of data, or a record. In ZOS, Data is grouped as records without using such termination characters. So part of the definition of a data set includes the information necessary to allow the system to recognize how big each record is. As seen in this example, the data is also represented in hexadecimal, but there are no special characters to indicate when a stream of characters end. Instead, the system processes them according to the predefined record size. As a result, each record is the same size, regardless of whether it contains enough data to fill each position.